Today we're going to look at definite integrals with u substitution. So we're going to go through the u substitution process. And then with definite integrals, that's the one where there is a number on the top and the bottom. So we're going to go through the u substitution problem, then we're going to plug in the top number, plug in the bottom number, and subtract those two values, just like we did before with definite integrals. So for our first example, we have the definite integral from 1 to 3 of x times x squared plus 1. Okay. So this part in parentheses, this is what I'm going to pick for u. So when there's the number here, it doesn't change anything from the start of the process. So we're still going to pick out our u, and then we're going to find du from here. So the derivative of x squared is 2x. The derivative of 1 goes away. So this is the part that's u. So that's just like u to the first. So we'll do power rule when we take the antiderivative. This is the extra part. Okay, so the leftover part just goes over here off to the side. And we need it to match dx. Okay, so I need to multiply by 2. So on the outside, I need to divide by 2. Now that I've matched du, this part's just going to go away once we do the antiderivative. And so then from here, it's just going to be our power rule. So add 1, that makes your new exponent 2, divide by 2. So that will be 1/4 u squared. We don't need the plus c for definite integrals. Okay. So then what I'm going to do is put the x squared plus 1 back in. And then I'm going to plug in 3, and I'm going to plug in 1, and I'm going to subtract those two numbers. So remember, after you do the integral, okay, the little integral symbol goes away. So that's after you've done the antiderivative. Once you've added 1 and divided by the new exponent, then instead of writing the integral symbol, we just put it on with a bar at the end. Okay. So I'm going to plug in 3. So I'm going to have 1/4 times 3 squared is 9. Plus 1 squared squared. So that's going to give me 10. 10 squared is 100 times 1/4 is going to be 25. And then I'm going to subtract what I get when I plug in 1. So when I plug in 1, I'm going to have 1/4 times 1 squared is 1 plus 1 squared. So 1 plus 1 squared is 2. Squared is 4 times 1/4 is 1. So 25 minus 1 is going to give me 24. So when we're checking your work on these problems, what we're going to look for is your antiderivative and then the numbers you got when you plugged in the top number and the bottom number. So my next example. We've got the integral from 1 to 5 of 3 times the square root of 2x minus 1. So u is going to be 2x minus 1. And then the derivative of this, so you're always going to pick the part inside the root. Then the derivative of this is just 2. So in my integral, this is the part that has u. So I'm going to write that first. So that is u to the 1/2. Remember, a square root is 1/2. If it was a cube root, it would be 1/3. If it was a fourth root, it would be 1/4. This is the extra part. Okay, so anytime the extra part has a number, I am always going to move the number to the front of the integral. Okay. But then I always have to have the extra part off to the side that matches du. Okay, so I'm just missing the 2 altogether. So I'm going to put the 2 here, divide by 2 outside. Okay. So now that this extra little part matches this, now I can ignore it, and then I can go through with my power rule. So I'm going to add 1, which is 2/2. That makes my new exponent 3/2. So 3/2 divided by 3/2 is just 1. So that's going to be u to the 3/2. I don't need the plus c. Then I'm going to go ahead and put that 2x minus 1 back in. Then I'm going to plug in 5. I'm going to plug in 1, subtract the two numbers. So when I plug in 5, that'll give me 10 minus 1, so 2 times 5 minus 1 to the 3 halves. So that is 9 to the 3 halves. And remember, when you have a fraction exponent, the top is the power, the bottom is the root. Okay, so I usually do the root first because it makes the number smaller, then the power second. So this is the square root of 9, which is 3, and then 3 to the third is going to give me 27. Then I'm going to plug in 1. So 2 times 1 is 2. So then we'll do 2 minus 1 to the 3 halves, which would be 1 to the 3 halves. So this is the square root of 1, which is 1. 1 to the third, also 1. So 27 minus 1 is going to give us 26. Now let's look at one that's a trig function. Okay, so remember, when we have a trig function, we're always going to pick the part inside the inside the trig function to be u. So then the derivative of that is just going to be pi. Remember, when it's just an x, the derivative is just the coefficient. So on this part, this is the part that has u in it. So I'm going to rewrite that as cosine of u. And then I have to have an extra part that matches du. So I'm missing the extra pi. Okay, so this pi x, this whole thing turned into the u right here. Okay, so we were missing like the pi in front. So I have to put a pi in here. So I have to divide by pi on the outside. Okay. Now that this matches, I can ignore it. And then I'm just looking on my integral sheet. So I'm looking for the integral with cosine in it. And I can see that goes to sine. And it would be sine of whatever we have for u. So this is going to turn into 1 over pi sine of u. And then I'm going to go ahead and put that pi over x back in for u. So I'm going to have 1 over pi sine of pi x. Then I'm going to plug in 1 for x. I'm going to plug in 1/2 for x and subtract those two numbers. So for the first one, I'll have 1 over pi times sine of pi times 1. So that's just pi. Okay. So we need to evaluate this part first. So pi is on the left. So that ordered pair would be left 1. So x is -1, y is 0. And remember, the y coordinate is always our sine value. So this part is going to turn into 0. So 1 over pi times 0 is just 0. Then I need to plug in 1/2. So that's going to be 1 over pi times sine of pi times 1 over 2 is pi over 2. So pi over 2, that is on the top of the y-axis. So that's over 0, up 1, so 0, 1. Okay, again, we're looking at the y value since it's sine. So sine of pi over 2, that just turns into 1. So 1 times 1 over pi is just 1 over pi. Then 0 minus 1 over pi is just going to give us -1 over pi. Now let's look at one that is a rational function. Okay, so meaning we have something in the denominator. So I still want to pick the 2x plus 1. Okay, that's the part inside the square root. Okay. So then my du, the derivative of 2x is just 2. The derivative of 1 is 0. So I'm going to rewrite my integral. This is the part that has u in it. Okay, so remember, first, if we have anything in the bottom, we need to move it up. and we're going to make our exponent negative. This is the extra part. Okay. I am always going to take the extra part, especially if it's just a number. I'm always going to take the extra part and move it outside, whether it matches du or not. Okay. Then this leftover part, this is what needs to match du. So I'm going to put a 2 there. So I'm going to divide by 2 on the outside. So 2 divided by 2, that's just 1. U to the negative 1/2. We can ignore this now that it matches. So now we're going to do our power rule. So I'm going to add 1. So plus 2 over 2. So I'm going to take this 1 that's on the outside, divide it by my new exponent, which is 1/2. So that's going to be 2 u to the positive 1/2. And then I'm just going to put the 2x plus 1 back into the problem. Okay. So then I'm going to plug in 4, plug in 0, subtract those two numbers. So always plug in the top number first. So that's going to be 2 times 4 is 8, plus 1 to the 1/2. So 8 plus 1 is 9. So this is 9 to the 1/2. Where 1/2 means square root. So the square root of 9 is 3. So that's 2 times 3, which is 6. Then I'm going to subtract whatever I get when I plug in 0. So that's going to be 2 times 0 is 0. So 0 plus 1 to the 1/2. So 0 plus 1 is 1 to the 1/2. So square root of 1 is 1. So that's 2 times 1, which is 2. And then 6 minus 2 is going to give us 4 for our final answer. Now let's look at one more rational function. So we have 3x minus 3 over x squared minus 2x cubed. Okay, so u is going to be x squared minus 2x. You're always going to pick the part in the parentheses with the exponent or in the root. So du will be 2x, the derivative of x squared, minus the derivative of 2x, which is just 2. So I'm going to rewrite my integral. This is the part that has u with it. So I'm going to write it as u to the negative 3. So I'm going to move it up, make the exponent negative. This is the extra part. Well, I'm able to GCF a 3 out of that. So since there's a common factor, since I can take a 3 out, I'm going to move the 3 to the front. And what I'm left over with is the x minus 1. Okay. This is what needs to match du. So in order to make this match 2x minus 2, I need to multiply it by 2. So on the outside, I want to divide by 2. Okay. Now I can ignore this, okay, and do the antiderivative. So add 1, divide by your new exponent, which will be negative 2. So 3/4 divided by negative 2 is going to be negative 3/4 u to the negative 2. Okay. Then I need to put the x squared minus 2x back in, and I also want to move this to the bottom to get rid of the negative exponent. So I'm going to have negative 3 over 4 times x squared minus 2x squared. Then we're going to plug in 3, we're going to plug in 1 and subtract them. So when I plug in 3, I'll have negative 3 over 4 times 3 squared is 9. So that'll be 9 minus 2 times 3 is 6, and then square it. Okay. So 9 minus 6 is 3. Squared is going to give me 9, times 4 is going to give me 36. So this is going to be negative 3 over 36, which I can reduce to negative 1/12. And then I'm going to plug in 1, and that's going to give me negative 3/4. So I'll have negative 12 minus a negative 3/4 for 2